this tutorial using the Console.h header file. Now, the header file has a few possible uses that you can utilize if you see fit. All you have to do is just copy the contents that are in the description that leads to a paste bin, and just make a new header file and paste all this code in, which is a grand total of 279 lines, and you will have all this functionality. There may be more lines and more functions as time goes on, and I'll implement them and maybe update the Console.h header file if I find new useful commands and functions, which I do want to add, but can't think of anything else right now. If you have experience with C++, please contact me if you can to give me any ideas you have to possibly improve the Console.h file, to add a little more functionality, because I would like to see more possible things to add that could improve it. But right now there are timestamps on the screen, and there will be some in the description showing all the possible times you can go to find out all different functions for this header file that you can utilize. So let's go ahead and start off with a few demonstrations here. I'm going to turn this down a little bit. Now, with that being said, let me go ahead and start this and get the microphone positioned. I'm going to start out with a few very basic commands that are meant to kind of make it a little bit easier. In C++, to print out text into the console, you have to do this. You see, that's a lot of typing, but it becomes second nature over time. However, I thought, you know what, let's make something of it maybe a little faster. One of the two namespaces in this Console.h header file is Namespace console. So let me show you how you put this in. Okay, so Console.sp. SP stands for Style Printer, and Style Printer is a class. And this class allows you to print out text into the console, and we'll get into more functionality later. But right now we have this. As you can tell, it makes it a lot easier to type it out. Now, inside the header file, I have a few namespaces that you can automatically do here. For using style is equal to Console.sp. If you want to, you can do that, so where all you have to do is now is all you have to do. So you can make it even faster if you wanted to, but without using style, it just makes it a little faster to type it out like this. Now, there's a few limitations to this, and there's a reason why I'm only suggesting you do this if you just want to print out an entire string, or like a single string variable, or an array of characters. Because if you don't do it like that, there's a chance that this will fail. Because let me show you. As you tell, we're getting a compiler error. This does not work. That's why I suggest you to just simply, if you were trying to do more than just one constant string, or trying to do multiple arrays or whatever, either use a string variable to combine them, or just simply use the stdcout method that we are all used to. Now, there's a way to print out a new line as well, using out.l, which means output line. And when I do that, I'm going to do hello. And if I try to print out the next thing that I'm going to put in here, let me show you. Alright, so now let me run this program. Hello, sir. So, there you go. And it prints out the new line, and it's all good. And if you do out and then out.l, it'll print it out into the first line, and then go to the next line in the end. You see, hello, sir. There you go. It's all set and done, ready to go. Now, there's another little command here before I get into that, I now want to segue into the next thing, which is the clear and the pause commands. And this brings me to another little something here. There is a little thing that I'm calling system procedures. And system procedures are basically a procedure to performing a certain action. And these classes use inheritance, so where you need to put in a specific class to make it perform its actions. So let me demonstrate this for you. I'm going to do a clear. So let me show you how to clear out the console, because with this you can clear out the console or pause the program entirely until you press a specific key or press any key. Let me show you. The first thing that this takes is a pointer to a con object. Con is a superclass that is filled with abstract methods that the two classes Win and CPC inherit. What that means is, for those of you who are not familiar with polymorphism, what it basically means is you need to pass in a class to make this work. And since it's asking for a pointer, you need to provide it with the ampersand. This ampersand basically means the memory address of whatever I'm about to put in. Since this is asking for a pointer, it obviously needs the memory address to the object for it to work. Now, there are two classes that you can provide here, and these two classes are the procedure types. These two procedure types are as follows. Console CPC, and lastly there is also Console Win. The difference between these two is Console Win stands for Windows, and CPC stands for cross-platform compatible. And with the names, it's pretty obvious. When you use Win, it basically does the Windows PowerShell versions of these commands, where it uses system to perform a PowerShell program to clear out the console or to pause the program. Now, if you don't want to use the Windows, you use CPC, which means cross-platform compatible, which basically does the same exact thing but differently. For the pause in particular, for console pause, you can use either one, but let me show you with clear. With console clear, I highly suggest you use the CPC version, because with the Windows version, it slows down the program. Since it's running a PowerShell program, basically what happens is it forces the, it's not only like really resource heavy, it also, if you're in release mode, because in release mode you cannot see the console, but if you try and clear the console using the Windows system procedure, it will bring up the console for a split second, and it will slow down your program, and it's not good. So for clear, I always suggest you use the CPC method. This way it works. Now, with pause, however, again, when you use the Windows versions of the system procedures, it is very resource heavy and it can slow down your program. However, when you're pausing your program, that doesn't really matter at all, because since you're already pausing your program, any sense of like slowing down or any resources that are being used to pause the program does not matter, because the program is still paused in the end and you still have to press a key to continue it. So that's fine. But with console clear, I would highly suggest you use console CPC. Now let me show you what happens with the two different pause commands. Okay, so now we have this right here. So I'm going to show you what happens with each one. So first of all, there's this clear. I'm just going to quickly print something out. So I can tell you. typed out. Let me go ahead and run this program. You see, it says press enter to continue. With the CPC version of the system procedure, you can only press enter, because otherwise, if you just type out, it just puts this into the console. Nothing happens until you press enter. However, with the Windows version of the pause command, all you have to do is just press any key. I'm pressing the number 5 right now, and there you go, it ends. So for pause, I would suggest you use the Windows system procedure. But for clear, I highly suggest you use the cross-platform compatible procedure. That and the Windows procedure may not work on some systems. So if you want to be careful, I would suggest you just always use CPC. But if you only want this to really work on Windows, using the Windows procedure with the pause feature, it might be a little better, since you just need to press any key for it to continue instead of just having to press enter specifically. Now, with that being said, let me move on to the next feature here. As you remember, there's a class called SP, which is style print. However, there is a nice little feature here that you can use if you want to make typing stuff out a little faster. Because what you don't want to have to do is print out something into the console and then do this clear method every single time. That can be a little annoying. There's a way to write this much faster. Because instead of having to do console clear and then print this out, you could instead do this. Okay, so now we have this. We have Console.h out, high, and then we have out capital C. What's up with this? Well, what this basically does is what it does is it clears out the console and then prints out this text. If you go to the definition here, you'll notice what it does is it does console.print. And then it does contents con new line true. If you go to print here, or at least this version of print, what it does is clear action. And if we go to clear action, there are two versions of it. Let me quickly just go to the normal clear action that you're currently calling, which should be, if you're running in CPC, it will do this, which clears out the console. So with that being said, you pass it in here. So let me demonstrate this. Everything before me is clear. As you can see, there is no high. That is because it cleared out the console. So instead of having to print this out and then do console clear every single time like this, and then that can be a little annoying. But now all you have to do is just do out C. Now remember, out C requires you to pass in one of these right here, one of the system procedures. Now what happens if you wanted to print out a new line afterwards? Because right now this is still on the same line. So let me demonstrate this. Okay, so right now I'm going to run this program and it's going to be all on the same line. You see, it's all in the same line. Now, there is another argument that you can put in. If I put a comma here, you'll notice there's one last argument that this can take. Boolean new line is equal to false. False is the default. So if you don't put anything in arguments right here, it will not print out a new line. However, if you want a new line to be printed out, you want to add in the argument parameter of true. Once you do that, I'm going to run this program right here. I'm going to run it, and as you can see, it goes to the next line right here. So everything's fine here. Now just remember to pass this in and make sure you're using the ampersand since it's using a pointer. But as you can see, everything is fine now. Everything's working. Okay. Now we're going to move on to the bulk of this, which is the color. color-related commands, which may interest most of you, but some of you might be interested in the timer stuff. I'll get to that in a minute. But for right now, let me demonstrate to you how to use the printing of color into your console. And there's a few features that you can use to this. So, using the color is very simple. It's literally almost exactly the same as the out, except using the commands that print out color requires you to make an object. You can't, these methods for printing out color are not static, meaning you have to call them through an object. So right here what you need to do is you need to make an object. And the object you need to make is an SP object. You can tell I just made a new object here, and everything's fine. And I made it the default constructor. So right now we have this, and when I bring down here, you can tell there's a bunch of different stuff here. Out and out L. Now there's also output C, and output L. What this is it allows you to output things in color. So let me demonstrate this for you. There is no constructors for this method. There's only one of this method, and this first takes in contents. So let me show you what happens here. I'm going to put in the contents. Next, there is const unsigned int foreground, and then const int background. What this is asking for is, well, it's asking for an integer, but it's actually asking for the enumerator. And what enumerator is it needing? Well, the console namespace has a bunch of enumerator variables that you can use, and these enumerator variables are named with color names. And as you could assume, this is because the colors are responsible for making this work. If you do not do anything right here, if you just do sp output hello world, what it basically does is it prints everything out in the default colors, which of course the foreground being the text is white and the background is black. And this is fine. You can do this perfectly fine. You do not have to put in color parameters. So for this instance, when I do this, I'm going to do F5 to run the program. I'll build it and then run. You're going to see it's hello world. It is not colored at all. However, now what I'm going to do is I'm going to provide an argument that changes the color. Let me show you. You may notice there's things like beige, black, blue, brown, crimson. There's a bunch of this stuff. Right now I'm going to make it crimson. Notice I have not provided a background, I have only provided a foreground. This is still because everything is default to its default color if you do not provide an argument for it. And right now I'm only providing an argument for the foreground, aka the text. As you can see, hello world is now colored. Now, what I'm going to do is I'm going to provide a background as well. And I'm going to give it a blue background. As you can see, I am not highlighting it. It is hello world with a blue background. And as you can see, everything's fine. Now, one thing to keep in mind, this is only going to work with this print command. When you change these colors here, they are not changed permanently. They are only changed to print out this specific text. So let me demonstrate this. As you can see, or not is perfectly default. This is because it is not a permanent change, and let me show you why. In the output command, there is a method that is called toDefault, and this basically changes the colors back into their default state. So yeah, you don't have to worry about that. They're not permanently changed. So in that moment, this will be normal. And of course, if I were to do sp output again, or output L, and I provide new colors, it will show those new colors. So, with that being said, there is also SP output L and output C. So, because if you notice, it says 2 of 2, because there is a constructor for output C, but I will get to that later. For now, all you have to worry about is this is basically the same as Console.h out C. So let me show you. Right now, I just made it to where it's going to clear out the console using the CPC system procedure. It's going to print out goodbye, sir. It's going to add a new line, and it is going to be printed out with the color of cyan as its foreground color, and it's going to use the default background color. And I just said all that. Let's see if that's true. As you can see, it cleared out everything before it, and now it is blue. So as you can see, it's working just fine. Output C. So, why is there a constructor though? Well, that is where I get into the arguments. Because I wanted to make this header file to where if someone is actually using it, it is as easy as it possibly can be, and it doesn't waste time. Because right now, having to constantly provide this or these colors can be a little annoying. So there is a way to change this. Right now, what you can do is in this constructor right here of SP, you can provide arguments that change the default colors. You see, this is the default. But then there is const unsigned int def foreground and background. This constructor requires you to provide a foreground, and you don't have to provide a background. This constructor, what it's going to do for you is it's going to set it up to where when you go back to default colors, it goes back to these specific colors. So let me show you. So as you can tell, there is no errors, meaning this worked correctly. Now, right now, these are the default colors, but you're going to see something in a moment. If you were to make this constructor, the colors are currently set to default, but when you run this program, you may notice that the colors are not changed. Why is that? Well, when you made the constructor, nothing was changed. All it did was set up the default colors. But right now, the colors are not set to default right now. How do you make it to where you set the colors to default so when you run any of these print commands, it prints the text out in those default colors? Well, here's how you do it. If you do sp to default and then run this, you will see that it now prints it out with black text in the white background, snow white background. This is how you make it set to default, because this does not automatically set the colors to default. It just sets up the variables that hold this information. But to actually change the console color, you need to do sp to default. In this way, when you print out anything using the std cout or printf, or of course Console.sp out, it will print it in that default color scheme. Now, what if you want to change the color palette? Let's say, for instance, you're getting a little tired of using black and snow white. Let's make it to where I want to change to something else. The way you change this is doing it like this. You may notice it takes two separate colors. That's because you can technically just make this default, like literally the normal default color scheme, but I'll get to that later. right now I wanted to change the default colors, so let me do that. As you can see, I set the default now. Everything is A-okay. So when I run this, you may notice something though. Nothing has changed. Well, oops. Once again, remember, you have to provide it for yourself. Because, of course, this is not going to work out correctly right away. Because remember, if I were to go to set default here, all it does is set up the default, but it does not do toDefault. It does not call that toDefault method. That's why you need to, once again, if you want to set a default, you have to then do because let me show you what happens when I run this. This is before I do sp2default. Hi. Everything else is now in green, but you'll see that. But you see two highs. They're still in the original. However, if I move this after toDefault, once I run this program, everything will work fine because you'll see high and then a green high there. So there you go. Now, what if you don't want these colors anymore? Because what you could do if you're tired of having a default colored text, all you have to do is technically do this. This is perfectly fine. You can do this. Set default will basically set, because right now, if you notice, set default has two arguments that it can take in. However, these arguments are automatically set to white and then black, the default colors for the command prompt, if you do not provide anything for these arguments. So when you do this, what you're basically doing is setting the colors back to normal. And you can see this once I run this program, and you see that all the text is now fine, as you can tell, which is great. Now, here is a bit of a problem though. You may notice, once I set it to default, you notice I'm setting it to where it's all the default colors, so it doesn't matter anymore. However, I have to then call the toDefault method, which can get a little annoying, and it means I have to write an extra line of code. Is there a way to reset the color scheme without having to change my default colors and without having to call two separate methods? There is a way. All you have to do is do Console.h reset does exactly what you want in that moment. Because if we go here, it sets up the color to be the default color. So in that moment, when you run this, I'm going to show you. Right now, I have not done set default or toDefault, meaning the text that automatically shows up at the end of the program that you've been seeing should technically be brown and light green, right? Well, no. Everything's back to normal. If I were to print anything out after this reset method, it will come up in the original color scheme. This is because the reset method does not change your default color scheme. All of this is exactly the same. All it does is set the command prompt to write everything in its original colors. And that's it. And if you want to bring it back to where it's printing out the default colors, all you have to do is do. As you can see, everything's fine now. Now, what if I don't want to print things out with the default colors or with the default command prompt colors? What if I want to keep this like it is right now with brown and light green, but I don't want to print everything out with white and black background? Well, there's a way to do that, and that is how you utilize the out output methods. Because you see here, if you use the output methods, you don't have to worry about the default colors or anything else. Right now, since I have not provided anything, once I run this program, it is going to just make it default color right here. It's all default. Now, as you can tell, I'm setting it to the color brown. You can tell there was 2 default right here. So what I'm about to show you, it's fine. This gets printed out with the default color. Now I'm going to show you what happens when you use output not hell, in this way. As you can tell, it is not using the default color scheme or this new color scheme. It is instead using hi there, as you provided here. And remember, there is also output C for this. So if you wanted to clear out the console before this, what you want to do is, instead of going straight into providing this, you want to do comma now the next thing you want to provide here is actually a new line, because for this, for output C methods, it always goes in the order of string, system procedure, and then lastly it goes to if it's a new line or not that it's printing out, and then it goes into the color schemes. So what I'm going to show you right now is that. So I also want to print out a new line, and then there, now I provide it. So as you can see, everything's good. Oh right, I forgot. Much better, okay. Be sure to add the little ampersand. As you can see, everything is fine. It clears out the console, and now the background is very, very white. That's because currently the background is white snow, so yeah, that's great. Now lastly, there is one last little thing that I implemented into this header file to possibly make writing this code a little easier. Because as you notice, every time we do a clear method, if it be Console.sp, out C, or output C, we always have to provide a specific system procedure. Let's say, for instance, you always just use cross-platform compatible, which is a alright, smart option. But that just means, even though you already know you're going to be using this every single time, you're forced to provide this. Now, with console clear or console out C, you're always going to have to provide this. However, let's say, for instance, you want to clear the console and then print something out, but you don't want to have to constantly provide this here, right? There is a way to do this. Let me bring you back to here. There is one more constructor that you can do. As you can see, there is now a con pointer default system procedure. This right here is a necessary thing you have to provide if you want to do this constructor. And what you do is you provide, once again, ampersand, you can do this, and now your default pointer, aka your default class or system procedure, is cross-platform compatible. That is now the default system procedure. You don't have to worry about providing this for the output C command, and I'll get to that in a second. Once again, right now the default colors are white and black. I can change this if I want, doing comma, and then providing actually, let me, for a bit of variety. There, oh god, I'm good at typing. Okay, there we go. So console purple. There we go. So now we have set two default things. Now, here's the thing. For something like, no matter what, you always have to provide the con object. However, if you are doing the output C command using the object, what you can do is use the other constructor of that method, being like this. This right here is what you see in 2 of 2. You see, it's asked for a string, and then it asks for if you want to provide new line, but it never asks for the console. And if you see this right here, outputs color text into console with your default system procedure. So in that moment, all I have to do is do this. Oh, I should probably make it print something before it. Okay, let's do that again. Here we go. As you can see, it prints out high. A-okay, everything is grand. Alright, now, I just want to mention something though. Now that you've realized that, hey, I can set up a default system procedure, you also just noticed that this text is purple now, for some strange reason. Why is that? Well, that is because of one simple reason. Output commands automatically set to default, right here. Every time you call one of these, it automatically does to default, and this is just made to make it to where you don't have to write more code to set it back to default. However, if you want to, you can just delete this. Say okay, just know what you're doing if you're altering the header file. But as you can tell, it's a-okay, you can just do that. But for these commands that are highlighted in red, they always change it back to the default color. The static methods, the out L, and out C, do not do that, but these ones do. Output L, and output C all put your color back to its original state. And if you want that original color to be the default color, you can do to where it's always the default color, or of course, if you want to, you can do SP out C and then do this. Either way, it works just fine. And there you go. It is now all set. It's perfectly fine, perfectly wonderful. Now, you may notice, well, what if I don't want to have to constantly write console SP reset? Well, you see here, when you do console SP out, you're just going to use the color that's already been set or last been set. However, if you want to print something out in the original default color scheme for the command prompt, instead of having to do console SP reset every single time you call one of these methods, all you have to do is that. You don't have to provide anything, because remember, if you do not provide any arguments, it automatically does the default color scheme for the command prompt. So in this moment, as you can see, it's now black again. Oh wait, let me remove set default. Okay. You're going to see that high, and then it's purple again. And that's how you do it. That's literally it. You don't have to worry about it anymore. And just use this every single time you want to print something out that does not use a color. But again, if you do this, no is in purple. That's because it's using what's last been set. And if you want to make it to where you can do out L's that use the default color, you do not have to change the default color. All you have to do is do and then when it prints out no, it will go back to normal. And that's it. And again, if you want to change it back, see, it goes back to purple. And that's it. That is all you have to know about the colors. You can set the background color by doing the second argument, which is always background. and set it to whatever you want, and then of course you have this. And instead of having to remember a bunch of codes, you can just use the enumerators that are provided in the console namespace. And that's it. Now, with that being said, remember, by the way, you can also put a bunch of new objects, like you put, like, do this, to have different color schemes and whatnot. And of course, you can also use the heap if you want. So, and there you go. So now you have the SP pointer, SP, and it's a new console. There you go. So yeah, you can do whatever you want there. Now we segue into the next one, which is where we get into the second namespace of the two namespaces, being CEL, cell, and that stands for Console Extras Library. And what does this do? Well, it provides you with a few extra stuff that doesn't relate too much, or maybe not even much at all, to the command prompt, but I thought it still deserved to be included as like a useful extra alternative, or an extra way to make code writing a little bit easier to get stuff, blah blah blah. As I said, the namespace is CEL, so if you wanted to, you can do that, but I don't do that usually. I just use the namespaces because I prefer. But let me show you. The first thing you're met with is sleep, sleep micro, and time. But I'll get to these two in a moment. But you can tell there is a time class. This time class has a few things you can do. First of all, there is one static method that you can use. That static method is getTime. And all this does is just give you your system's time as a string. So when I run this, all it's going to do is just print out the time in the console, which right now it's 5/10/2019. You'll see 5/10/2019. Now, for those of you who are European or in different parts of the country that display dates in day, month, year instead of month, day, year, there is a way to change this. Because if I were to do this again, you'll notice that this method actually takes an argument. Bool American format is equal to true. It defaults to true, so Americans can just type this out normally. But if you're European, or your calendars read the date, month, year, all you have to do is put in false. And when you run this, it now provides you with this. And of course, you don't have to print it out right away, because what this is doing is returning a string. So everything's A-okay. So with that being said, now let me go and delete this. That's just like a quick little method, but that's probably not going to be much use for you, but it's just an easy way to do that in case anyone wants to do it. Now we move on to probably the most important member of the CEL library as of right now, or cell library. And this is a timer function that allows you to create a timer. And this can be useful especially for games, or maybe methods that you want to constantly execute as long as the timer is still running. So let me show you this. In order to use the timer method, you have to make an object, because none of the timer related methods are static. Alright, so here we go. Now we have a few things here. With CEL time, you do have the option to just simply make a default constructor, but that's just basically taking up space because that is useless. What you want to do is provide a time. And the way you do this is to use chrono. Now, right now, the Console.h already includes the chrono library here. It already includes it. So you don't have to worry about including it here. All I have to do is we go. What I just did here is I made a timer object, and this timer will be running for 5 milliseconds. And of course, if I wanted to, I can make it run for 5 seconds. I don't think there was minutes. I can make it run for 5 minutes. I can make it run for 5 microseconds. What it basically does is just creates the timer. So for right now, I'm going to make this timer run. Make it run for 5 seconds. Now what I'm going to do, usually when you use this timer, you want to use it inside a while loop. And this is how you use it. Okay, so what's going on here? Well, you notice that this is a method that returns if it is completed or not. It does not take any arguments. If we go to the isCompleted function, what it basically does is return if the end time is less than or equal to the current time. And what this means is if the end time is, well, basically what it's saying is if the timer is completed, it returns true. This is why you want to add this little exclamation point, which means not. If the timer is not completed, run this code. And that's how you do it. If you make a timer for 10 seconds, for 10 seconds this while loop will constantly run over and over and over and over again. So let me go ahead and make a little function here that uses that. Alright, so now I've made a while loop, and here we go, so let me run this. As you can tell, it ran for 5 seconds. It ran for 5 seconds, and it's done. And that's it. That's literally how you use it. All you have to do is just create a constructor, and there you go. And of course, you can make multiple timers if you wanted to. And that's how you use the timer. However, there's a few extra things you can do. And there's a few extra stuff that you're able to pull off. Because if I were to delete this, you may notice there is also the operators. And let me show you how these operators work. Let's say you have a game and you want a certain method to run for a certain amount of time. But let's say if you collect a collectible, you want to extend this timer by a certain amount of time. How do you do that? Well, it's simple. Use this timer, it runs for 5 seconds. Let's say you have a boolean. Let's say that it is originally false and then it becomes true. So, that's it. This extends the timer by 1 second. You could provide any time period. You could literally make it to where it just does it by 1 microsecond. As you can see, alright, I'm back. I just had to fix a bug here. So you can see microseconds, 1 microsecond, and now let's say I want to extend it by 1 second. You can tell it works just fine. Now, let me just extend it for 4 seconds so you can tell, or I mean 5 seconds so you can tell it most certainly extends it. So let me do this again. As you can see, it's going to do this again, so let me run this. Now you're going to see in a moment, it's running for a little bit, and right about now it should have ended, but it didn't. It's still running. still going, still fine, and then it ends. Proof that it worked. It has officially extended the timer. Now, there you go, that's simple as that. Now, there's one problem though. Let me give you a demonstration of what could go wrong, and before you have this problem, I'm going to demonstrate to you why this is a problem. So, what I'm going to do is I'm going to make it to where I pause this program for a moment. Right now, we have this. Alright, so let me go ahead and extend this timer a little bit. Right now I've extended the timer by 2 seconds. Oops. And while this is happening, I'm going to make the program once again begin printing out yes. Alright, so press any key to continue. All of a sudden it ends. Why did it end? I waited a little bit, and then it ends. Didn't I tell it to go ahead and add extra 2 seconds? Well, here's the thing. When a timer is completed, it is still counting. And as it's counting, that timer is always going up over time. And when you add 2 seconds, all you're doing is just adding 2 seconds to what was the end time. Meaning, if you waited at this pause method for longer than 2 seconds, it will not execute this at all. How do you fix that? How do you change that? Well, there is an operator to fix this, because right now this could be a very big problem. And the way you do this is you, instead of doing this to where you add to the time, there's a way to reset the timer and then add another time, kind of like making this constructor but using an operator. The way you fix this is using the left shift operator. As you can tell, there's no errors. This is because the left shift operator allows you to add 2 seconds. Now here's the thing though, if I were to go to this operator, you will notice 10 is equal to STD chrono steady clock now. This right here resets the timer. So if I were to go over here, and if I were to run this program, he's going to run for 5 seconds, and then when it reaches 5 seconds, it's going to prompt me to press any key to continue. And you see now it's printing out yes again, and then it ends. It did it for 2 seconds, and then it ended. This means it worked. As you can see, it resets it. So remember, before you make the mistake of causing any issues, if you want to just simply add onto the timer, like for instance, if you collect a collectible in a game, and it's meant to extend your time for a certain function to happen, you need to use the plus operator. However, if you want to reset the timer and then add some time, then you want to use the left shift operator, which basically makes the timer last for 2 seconds. Remember when I made the timer last for 5 seconds? This is basically the same thing as doing this. However, instead of doing it here, you're now doing it here. Simple as that. And that's how you use the left shift operator for resetting the time and setting a new second count. Now, there's a few other ways of changing the timer and its current contents. Let me create another timer object here. I'm going to purposely just use the heap just for the sake of it, for demonstration. As you can tell, this timer is lasting for a solid 20 minutes. That's quite a long time. Now, you notice here, this is a pointer. This is because I'm using the heap, and I have to make this a pointer. So this is just kind of for demonstration here. So right now, what I want to do is I want to make the timer equal the timing. And the way you make timer equal the settings for timing is using the left shift operator. If you're a C++ programmer, you're used to using the left shift operator for using stdcout. And the way I've always visualized this is when you use the left shift operator, it's basically using the string and feeding it into stdcout, like this. And basically what it does is it shifts this text to the left into here, and that's how I've always visualized it. So with that in mind, the way I wrote this operator is like this. There you go. So what just happened here is I do a left shift operator, and now timer should have the same settings as this. It should have the same exact starting time, and it should have the exact same the time left, aka the 20 minutes. So when I do this, I'm going to go ahead and redo the thing over here. I don't even have to print anything out. I'm gonna run this program. Technically, this should only last for 5 seconds. Right now, the program's currently running. You don't see anything, but that's because it's doing this. Nothing's actually happening, but it is running right now. However, you may notice nothing's actually happening. It's been past 5 seconds and it's still running. Well, that's because it is now lasting for 20 minutes straight. It is officially taken the timing from the timing method into here. Now you notice I have this little star. This is a dereferencer operator to dereference this timer's pointer. If you want to make it to where it's just a normal object, of course, instead of having a pointer, you can do this. There you go, and then you remove that, and there you go. It's the exact same thing. See, it works. However, when you use a pointer, or of course, use the heap, you see there's an error here. This is because it's not asking for a pointer, so you need to dereference this pointer, and there you go. If you have used pointers before, this should be second nature. Okay, but let's say for instance I found out that apparently making it last for 20 minutes is a little ridiculous. So what do I want to do? Because right now timer is equal to this. That's a little long. I don't really like that. Well, there's no way to do that because again, it's a bit of a problem. So, what do I want to do? Well, instead of doing this, what I can do now so right now there is the minus operator, and what the minus operator does is like similar to the plus operator, except it returns a boolean. This is because if the timer is already past its now point, aka if the timer has already ran out of time, it will not do this method and it will instead return false. And since it's returning a boolean, you could maybe like make it to where it prints out a message if it doesn't do it correctly or something along those lines. It's up to you. So yeah, but here you go. So you can see it works. There you go. Now when I run this, what's going to happen is I'm going to run this. Three, four, five, and it's done. As you can tell, it did not last for 20 minutes, so that means this minus operator did work. Great. Okay, now let's say for instance, now instead of using timer, I want to use timing. Oh right, what am I doing? Oh god. There we go, perfect. Okay. So now, right now timing is lasting 20 minutes, and that's a little ridiculous, not gonna lie. I don't want to wait 20 minutes. However, timer is set to 5 seconds as of right now. How do I make the timing equal to the timer stuff? Well, there's two ways to do this. Right now, you have the left shift operator. So what you could do is do dereference timing. This can work as well. You do this, now timing shares the timer's counter. However, there's another way to do this. Let's say, for instance, you don't want to have to remember to switch it over. And let's say if you do forget to switch it over and then you have a big bug that confuses you, you have no idea what's going on. What you can instead do, since you know how to left shift is shifting it to the left, you now can do this. This does the exact same thing as putting timer here and timer here with the left shift operator. What it basically does is it shifts the timer's settings and it puts it into the timing settings right here. And to demonstrate this, I'm going to run this. Right now, timing, if this did not work, this should last 20 minutes. However, when I run this program, it's going to last 1, 2, 3, 4, 5. Yeah, there you go. See, it worked. And that's how you use the right shift operator for this if you want to like feed it into here. You can basically think of it as an object is a person, and it's basically giving this to this. And of course, with the left shift operator, it's basically the opposite. This guy is all lonely, and this guy comes over and says, "Hey, I'm gonna give you some love. Pass it to the left, and then pass it to the right." So there you go. So if you have a blunt and you need to pass it over to the left, there you go. You do that. Anyway, so yeah, that's how you use the timing. Now, there's one more thing you can do with this, because this is all you have to know about it. There's nothing else you can do with this. You can use this with your heart's content. But there's one more thing you can do. If you remember, I was trying to do the sleeping method, where it basically makes a thread sleep for a set amount of time, which is like a really lot of typing. As you can see, there's a lot of typing going on. Instead of doing all of this typing, it's getting really long. You can do instead. That's it. And you see, sleep, it automatically does milliseconds. I did this on purpose because I don't want you to have to constantly put in STD chrono seconds or whatever. Because usually thread sleeping, they usually make it like 2 or 5 milliseconds or something like that. Just enough to make the CPU have a bit of a breather, especially in a while loop and like a game loop. But right here, all you have to do is just provide milliseconds. So if you put in 5, that means the thread is going to sleep for 5 milliseconds. And that's it. That's all you have to do. Instead of typing out all the code that requires to make a thread sleep, you can just do this. If you want a thread to sleep for 2 milliseconds, there you go. Now let's say, for instance, you want to make it sleep for less than 1 millisecond for some reason. Well, there's a way to do that. Sleep micro is basically taking in microseconds. So if you want the thread to sleep for 5 microseconds, there you go. In this case, you can do something like 300 microseconds. So basically 3/10 of a millisecond. There you go. So there you go. That's it. It's the sleep method as well. And that's the whole header file. I've been recording for probably a grand total of an hour. So hopefully this is enough for you all to be able to use this header file and utilize it. If you have any other ideas that you could implement into this, any ideas you have, there you go. And that will help me out. So there you go. And of course, if you want to, you can just copy all this out, so you don't have to constantly worry about it. Namespace, console, namespace, sound, and style, print, and then time. It'll allow you to just simply call in these objects. So yeah, thank you for listening and watching, and have a nice day.